Hello and welcome to Apropos, a conversation between Clojure programmers that you can watch not live on YouTube. We're going to discuss a few Clojure news items and share our opinions on them. We don't have a REPL exercise, but sometimes we do that. Well, I think that's it. Let me introduce the panel. We've got a Mike.
Hello.
A Mia.
Hello.
A Ray. And
Good
I
evening.
am Eric. Hello.
I said good evening, but really it could be any time, I guess.
Who's counting anyway?
It's relative.
Do we want to switch the view to panel view? Can we do that?
Oh, like the Brady Bunch?
Yeah.
I think
Yeah,
you're asking for too much technology. I don't know how to do that. You know how
I've
to
got
do it?
mine on
I did it on
gallery.
my screen, yeah.
Yeah.
What are we recording? I don't even know how this works. What
I
is
don't know.
getting...
Maybe
Okay.
we cut this bit off as well.
Yeah.
The first 5 minutes of Apropos is just Apropos learning how to use
I will splice back in the introduction.
Ever
And
since
go,
YouTube
Eric,
Live
yeah.
went on. Yeah. All right.
Ah.
So we have some topics to talk about. So Mike has been doing some hardware hacking. Mike,
Have you
can you
heard of
tell
it?
us about this project, Mike?
It could be a show and tell. I have one.
Whoa.
Ooh.
So,
Look, it's a REPL, everyone. You can see it right there.
Wow.
So I don't know if so this is a microcontroller, and I've been dealing with microcontrollers at work. And typically, I don't know if you've had any experience with these things, but typically you program them using like traditional old school languages like C, right? I guess you could get fancy with what Ray was suggesting, Rust or whatnot, or but there are more modern things like there's a Circuit Python thing that you can run on microcontrollers, like a whole different, I guess, Python VM, if you will. And there's JavaScript things that you can run. There's perhaps like 3 or 4 of them that you can run on these microcontrollers. Of course, I wanted ClojureScript to run on that. So what I did was I figured out how to get ClojureScript to run on one of these, and the main trick is this thing called Esperino. Remember, Mia thought that was kind of an interesting name, but Esperino is one of those 3 or 4 JavaScript engines that run on microcontrollers. And since it's a JavaScript engine, you can compile your ClojureScript down to it and run it right on there.
So you've
And
got
you can
a
establish a REPL into
self-hosted.
it.
You've got
It's
a
actually
self-hosted
not.
ClojureScript.
It's not self-hosted, although it's kind of intriguing. Maybe it could be. It's actually more of just a conventional ClojureScript REPL that makes a network connection into it. Because one thing that's cool about these, so the main thing that makes this possible, I think, I would say, is that this microcontroller is it's an ESP32, and the main things about it are it has a lot of RAM, like megabytes of RAM, and it has a Wi-Fi and Bluetooth antenna and capability kind of built into it.
Okay.
So it's not just a processor, if you will. It's got the ability to join your LAN and talk to things. And because of that, you can imagine making a TCP connection into it and controlling it. The way Esperino works by default is it makes a serial connection into it. But any way you want to talk to it, you can.
So you have a REPL running on your machine
Yeah.
that is compiling the code to JavaScript
Yes.
and then sending it to that device
Yes.
and where it runs. And
Where it
then
has a JavaScript engine. Yeah.
and then the result is sent back to your terminal
Yes.
computer.
And that is no different than a normal ClojureScript REPL with a browser.
right.
That same pattern. So the
microcontroller is the browser.
basically, yeah, that's a good way of looking at it. Yeah.
And so then you're running JVM ClojureScript on your machine.
On a machine, yeah. So you can REPL into it, and you can control it. And the cool thing, in my opinion, is the REPL, really, because normally you would write, if you're dealing with a real microcontroller, you would write some C, compile it,
Right.
perhaps have a debugger connected to it live, and you could step debug through your stuff. But it's the typical cycle where you're like, make a change, recompile, cycle back around.
Right. You lose
So
all
with the
your
REPL,
state.
Yeah. I mean, of course, in addition to just the REPL, is the whole closure script, immutable state, and programming paradigms, right? You get all that. But to me, that's the cool thing. Is like typically if you're doing a microcontroller or doing anything with it, you're using it to do something with something else, right? You're not just using it to compute something.
Turn on a light bulb.
Yeah. So typically these are like you're kind of mutating the world or interacting with the world, and that's where a REPL is really cool, because you're turning on the light bulb or turning it up, or
Yeah.
And these are like typically they have little what they call GPIO pins that come out, so you can connect it to things and drive things or sense things from the world. But
like a hacker.
Yeah. So one thing, so you don't need to be clear, you don't need one of these boards to do this. All you need is the ESP32. There's a couple of variants. There's a small one and a big one. You need the big one with the more RAM. That's called a W rover, as opposed to a W room.
What is it? And
Okay.
That's the microcontroller, and then what's
the silvery thing. If you were to, this is basically I want to call it an RF can or a shield. If you took that off, you would see the chips inside of it. There's like a little circuit board inside of there. And inside there's a typical, it looks like a microcontroller and maybe a few other ancillary chips in there.
So what's the rest of the circuit board doing?
Okay, so what I wanted to do, and this is kind of a gimmick for the talk that I gave at Closure North, was I wanted a battery-powered REPL, one that you could like unplug from your computer and just have it run. So all of this circuitry on the bottom is basically, here's one of these little like LiPo batteries. I've seen these things. I wonder if I have this thing set up, you could plug it in, and you could be REPLed into it, while it's running off battery power. Oh, there the lights are going. Yay, lights. This is just like a test pattern that I have it doing. But the point is you can basically hook up a battery. You can, if you plug in USB, it'll recharge it while so it basically kind of acts like a modern cell phone, right? Where it has a battery and it, winds down and you can recharge it. So that's what I wanted to do, is just kind of, as a gimmick to make the battery powered,
You have some pins out that you can control stuff?
Yeah, so along the side there, I've exposed some of them. Let's see, hold it really close. So you can and in the talk for Closure North, I gave a demo where it actually, show and tell, I have one of these locks, and I have it controlling the lock. It opens and closes it. And the cool thing about that, conceptually, is that this lock is like a 12-volt lock, whereas these little things run off like 3.5 volts. So this lock is driven by a larger power supply and whatnot. So it's basically this big honking thing that snaps when you unlock. So it's an example of you have a low-powered tiny thing controlling a bigger thing, and it's showing that you can actually control real things rather than just like light bulbs and LEDs. You can actually control locks and whatnot.
What's the coolest thing you've controlled with it?
I think the opposite is the thing that controlled it. Is I had ultra wideband hooked up to it. And that to me is cool, because ultra wideband is just this fancy new technology that is used to measure distance between things or locate things. So ultra wideband, I don't know if you've ever heard of that. So so the cool thing about it is it basically, I wonder if I have one of those lying around. Yeah, I do. Let me grab it. This is a ultra wideband device. Looking at it doesn't tell you anything about it, but what it's got in it, which is
like,
cool.
oh yeah, that's an ultra wide band.
So
I thought that was a ultra narrow band, but
that was a
good
normal size band, mediocre band.
So this is the cool thing. If you get two of these,
I really want to see what's on your floor now.
I know.
Oh, yeah.
It's like Bugs Bunny. You just
dive
reach
down
in and grab it.
Nah. So essentially, okay.
Like a scene out of Blade Runner,
Yeah. I think, all right, so this, I will
Dead robots
hopefully
is what it
convince
is.
you that this is cool. These things, they will send a little pulse, a chirp, across, that's why it's called wideband, because it just like shoots a whole bunch of frequencies at once, right? And it does it so quickly. These things have like gigahertz counters that they're like 40-bit counters that cycle every 17 seconds. They're going so fast. And when they do a chirp, they timestamp the data that goes out, and it goes to another device, and it can receive that and then perhaps respond back. And you can then use those timestamps and the speed of light to calculate the distance between the things down to like centimeter accuracy. So it's like GPS, but in the small. You have like these little things that are like doing just triangulation or ranging. And essentially you can use those, and I think you'll see them.
So like you put a bracelet on your kid, and if they get too far from
you can put
from their homework or something.
Yeah. So that's one thing that I like. Apple just announced stuff using this. They have ultra wideband and the most recent iPhone models, and you can use it to hypothetically, like if you lose your iPhone, it'll tell you where it is, but it might say that it's on your back deck of your house or something like that because it doesn't really know based on its location accuracy. Well, with these new ultra wideband things, with the new ultra wideband things, they're like centimeter accuracy, so you'll know exactly where it is.
Wow.
So they're
I think it's under the pizza slice.
Yeah.
So I think that the ultra wideband stuff is going to become popular. If it already isn't being used, it's like in factories, locating where things are, tag them as they move through the factory. At Vouch, we're going to use it to figure out how close you are to a lock or to your car to unlock it as you approach it, like proximity, and determine it, like, are you approaching the driver's side door or not? These are things you can't easily do with GPS.
Yeah, and that's a safety issue. That's really cool.
Yeah, so it's just cool, I think,
So ultra wideband, does this also function as a vector for spreading the novel coronavirus the same way 5G does? Or
let's see. I think it would be more efficient than 5G.
Targeted coronavirus.
But anyway, that is completely, all that ultra wideband stuff is completely unrelated to this. It's basically, I thought it was just a cool technology that I used to drive this thing, to basically actuate it, if you will, make it do things. Yeah.
That's really cool.
It's nice to hear about technology like ultra wideband, which is really convenient and nice, and somehow doesn't have to be used in a shitty way. I mean, you can imagine it could be, but you can also imagine, like you say, it's just used for things around your house and just for checking nice things and for making things more straightforward to find and just improve your life rather than having everything like looked at.
I'm sure you could do evil with it if you wanted.
Oh, for sure. Absolutely.
What's the range on ultra wideband?
Okay, so I have tried it out to about as far as Bluetooth can go, like 30 meters or so. But to be honest, I don't know if it goes farther than that. And it's all just a matter of radio frequency. They run it like above the 5G band, I think, 6 gigahertz, whatever. It's just a radio frequency thing. Yeah. So it's cool. And Apple just announced things, so you'll see that coming out pretty soon.
Man, that would be so great. Every time I leave my phone in my robe pocket and it doesn't, it's on vibrate only, so I can't ever find it because the ringing doesn't make a sound.
Yeah.
Wow.
I think it's like one of these, it's like a combination thing, isn't it? Because, people could use GPS, they could use Bluetooth, they could use NFC, but all of these things were essentially sort of hacks for proximity. NFC would have a deliberately narrow range so that you had to be close to it. But the nice thing about ultra wideband is it spans all of those possibilities. So you can reduce a lot of technology stack there and get the benefit of all of those things.
I would be interested to know the actual range of it.
So this is one of those things where this happened to me. You have to actually experience it to get a sense of it. Where I can describe this to you, and you'll take one of these devices and move it towards the other one, and it will, if you're having it lock or unlock a lock, which I show in the demo, it will do it. There'll be like this imaginary line or physical surface. So the way my son describes this is he thinks of there being like an invisible bubble around the car. You cross it, and it's clearly there. There's something there that you're crossing over, and it just snaps. Yeah, because it's so accurate.
So there's the ultra wideband to get the distance, but then how do you authenticate with the lock?
Yeah, so when you are communicating and sending that round trip thing that has the timestamps on it, you can include data in those messages that perhaps has things that are signed or whatnot, or whatever you want.
Right. Yeah. Okay.
You can devise your own
protocol.
Security.
Yeah, that's cool.
Now, did you just pick up an electronic lock from somewhere on your magic desk? to wave at us.
This thing.
Yes, I really. I'm just trying to get a sense of what's on
he's like,
your
"Hey,
desk.
Mike," because I was doing the thing where I was like lighting up LEDs and David's like, "Mike, get a lock." He found one. He's like, and this is it's very satisfying when you get it to go chink, Anyway, that's a solenoid-based lock, Yeah.
And you're doing that with ClojureScript.
This is in the demo I basically have ClojureScript running in it, and I basically hook it to this lock. And then I write a little program that, at the REPL that will drive the lock open and closed and whatnot.
And then you can have it, when it comes on, it just runs a program instead of using the REPL.
Yeah, so you could, yes. So you could even compile ClojureScript in its advanced form so that it's just there and ready to go. And when you turn it on. So one thing that has to be perhaps improved is the speed of starting these things up.
This is the point where the compiler optimizations that we always talk about, as academic, become actually really important.
Yeah, it's interesting, the minification that's done in Clojure Advanced was really for the web, right, to minimize the payload of your ClojureScript as it goes to the browser. But it really helps with these kind of things too. So when you start up a REPL with this stuff in it, what it's doing is it's loading all of CLJS core. Because you might call the map function, or you might call reduce. You might call any of these things that are in the standard library. So they kind of already need to be there. I mean, you could get fancy and load them on demand into the device, but the simpler way REPLs really work by convention is they have the entire ClojureScript runtime in there already,
right?
So that you can call any of the functions at will. So when you boot the device, the way Esperino works, or any JavaScript runtime, right? It has to run through all that code and parse all those things and kind of put them into play. And on a device like this, it takes about 15 seconds to bring the REPL up and get it going. Whereas if you do advanced, you can get down to 4 seconds. And I've even, what's kind of interesting is I was looking at that, when you start looking at these kind of things, advanced still leaves, quote, dead code in the mix. So advanced will statically look at your code and say hey, you're not calling this thing, therefore I can remove it. It can prove to itself that you're not calling any particular JavaScript function. But there still are functions that it can't see, don't ever get called at runtime dynamically. And those still remain in there. And I wrote a small program that did something non-trivial. It wasn't just a hello world. I wrote a little program that would reduce over some numbers and do a calculation. And I found that there was I could reduce it down to 1/8 of its original size by looking at all the functions and saying, is this one called? Nope, delete it and keep going through one by one. And you can't statically prove that to yourself. I guess maybe if you had a smart enough algorithm, you could look and say this, you can prove that this bit of code is not being called.
What algorithm is it using if it's not that smart?
Yeah, Clojure.
The Google Clojure compiler, because it seems like it should be able to know every function that could be called from the root export, right? Yeah.
So here's one example of this. Maybe this might convince you, and I think it might be a valid argument. Is if you have a multi-arity function, right? You can imagine when you call that, the dispatch to one of those arities could be through a dispatching switch. And it'll say okay, how many arguments did you pass? Let me then go look and see which of those multi-arity functions I'm going to actually invoke. And that could be a dynamic thing. Yeah, exactly. So now you're there.
Once you use apply, everything's out.
Yeah, it becomes too complicated. You could have AI look at it and say there is never a call to, So I think that's what's going on is there's just cases that are dynamic that you can't see. But in fact, you have that code lying around that you could.
It's cool that Google Clojure knows that, because I could imagine them saying, we just don't allow that. We don't allow code that has that it calls the .call method with different numbers of arguments.
I mean, that's a slippery slope. Then they could just be we don't allow bugs. I mean,
what?
They've already got so many restrictions,
When I first heard of tree shaking, that's what I thought it referred to. I thought it was running your program dynamically and shaking it, and finding what will fall out. I'm okay, all these branches fall off because they don't get called dynamically. But I guess
that's an interesting problem that would be great to solve. But also,
isn't this what sort of isn't this what JITs do essentially?
Yeah, they look at the runtime of the code and make a separate sort of trace of what actually gets called, and the next time that runs through, they just run that trace with some kind of check to make sure that the trace is still the right thing to do. Yeah.
But you have to be careful.
You still have to load the
remember,
code.
Yeah.
Yeah, remember there was a thing called Heartbleed from Intel.
I remember that.
And,
yeah,
that's what that was doing. It was basically allowing information to escape from the compilation pipeline. So you have to be a bit careful. I mean, that's one of the problems with some of this stuff, is that it's definitely a hard problem. And when you've got enough CPU, you can try and use it all to improve the execution of the code. And I think, if I'm not wrong, it costs Amazon, or it costs cloud providers in general, 30% of the CPU not to do that. If they wanted to just turn that off to remove the bug, it was like a 30% cost.
Wow,
that's real money for those people,
Yeah. Huh.
So sometimes you got to be careful what you wish for,
We found it. We found a hard problem.
Rust doesn't really help with the Heartbleed problem.
No.
So let's say you wanted to.
Well, it's branch prediction, isn't it? That's the problem.
Let's say you wanted to make this self-hosted. What would be the benefits of that, and how would you start going about it, do you think?
To put self-hosted inside one of these?
Yeah.
Yeah.
It would just be cool.
Okay. So, all right. So what I want to, what I would like is to be able to just turn this thing on and interact with it directly. As a matter of fact, I wanted the REPL to run across Bluetooth because at the time I thought I was going to be giving this presentation live, in Canada, and I was afraid, what if I couldn't connect to it with Wi-Fi? The typical conference thing, you're like, I can't get on Wi-Fi. So Bluetooth would be nice, but I couldn't find a good way to do Bluetooth from Java, surprisingly. If you go dig around, you're like, there's no good library to make a Bluetooth client to talk to it. I guess you can, but you get into these low-level things to make it work, and to me it's like, whatever, I'll just use TCP for now. So that was one thing I wanted to do, is just basically you should just eliminate everything else. And if you make it self-hosted, then the compiler's inside there, and you just connect to it, and then you say, hey, you have just like Plonk or Lumo or any of these are Replete, they're just the REPL's inside there, and you just connect to it, and you're good to go.
It's really this feels like a descendant of Replete. Like this feels like Replete being born into the world to me.
It came out of the phone, well formed like this.
Yeah.
And one day you could put a camera on it and some legs.
Yes.
And it could walk around. And...
So yeah, maybe making self-hosted next.
Oh, it's like a rubber duck that you talk to, but it's a REPL.
Put ELIZA inside. Fun.
I always wonder about that because I have some friends who are into hardware hacking and running small Lisps on these little devices.
Mm-hmm.
But I just never have a use case that would motivate me to spend the time on. Do you have any?
Oh, okay. Yeah, so that's a lot of people. They'll get one of these and what do I do with it?
Right.
Yeah, there's.
What do we do with it?
Yeah, I mean, it's an unborn baby. You can do whatever you want with it.
Oh, jeez.
Dream up things to do. Sorry, me.
Oh, jeez.
I mean, there's lots of things you could dream up, right? Like you can control things, make a lock on your house, or make it water your plants for you. I don't know.
I think one of the nice possibilities about these things, and sometimes it's kind of like the problem we have with convenience versus control, because you go and get a speaker from Google or Amazon or Apple or whatever, but you could easily kind of attach a speaker to this thing and have music coming out of it, for example.
So this is actually a use case. I have a use case. I wonder if I could do that with this. So very, 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 very soon. I'm going to be producing a newborn, and you're supposed to track them with these apps. Oh, yeah, no, it's like a whole thing.
I know now. I've seen it. It's ridiculous.
Yeah, you're supposed to track like how much they eat and when they eat and like when they sleep and how much they're sleeping and like what's their poop like.
When they burp.
And a lot of these apps have
the phone home, yeah.
They have interactions that you can set up with Alexa or with Google Home. And then that way you don't have to type anything into your phone. You can say,
you just say, Alexa, my baby pooped.
Yeah, my baby pooped. But, for us, we don't want those things in our houses.
Yeah.
Those are listening devices. We don't like them. So would it be possible to create something that would have a local interaction within our home that we could make talk to our phones in the same way?
Well, there are plenty of like Clojure-based or open source tools to do like listening and all this kind of stuff and talking, etc. So I think James Reeve has done some of this stuff. Actually, Weave Jester done some of these things. So you can definitely investigate those things. That's really
IoT without the internet.
Yeah.
IoT without the internet. Well, I think what you want is something like.
But okay.
You want something like a button, 2 buttons by your table, like the changing table, where you hit, dirty or wet, and that's it. And it just stores that somewhere with a timestamp. And you can do something else later with it. Put it in a spreadsheet or something.
Oh God! Wow, there's something in the Magic Desk.
So I pulled something else off the floor. This is a Raspberry Pi, right? Here, so this thing by size comparison is smaller. This is actually bigger than it needs to be. This was the first prototype I did. It was smaller than that one. So if you look, you don't, all this extra stuff on there is really for battery charging. You don't need it all. I have a picture I tweeted once where I had a Rebel just in the silver thing by itself. So you can imagine the size difference where, like, if you imagine I'm going to make something with a Pi that does something, right? The reason to go to these things is just size. You can reduce the size and fit it into something smaller. I recently made, there's a tweet I did where I have it in a key fob, basically. I don't have it lying around. Maybe it's on the floor somewhere. But I have a key fob that I'm using to unlock my car, which is like, it's got even smaller MCU inside of it, and it's not running ClojureScript, but it's smaller. And it's just an example of the kind of things you can build by just making tiny little devices, So now when I have a key fob that has UWB in it, and I walk up to my car and it unlocks for me automatically. And this key fob is small enough to actually, you can put a little keychain loop on it and have it in my pocket. So that's to me is just if you ever are dreaming of making something small that does something. These tiny little computers, these Raspberry Pis are cool, but they're kind of big compared to, like, you wouldn't want to put a Raspberry Pi in your pocket. But
you can have it in your lounge to do listening and stuff like that, and the Raspberry Pi is very extensible, Yeah,
it's a computer. It's a full-fledged.
The problem is by the time you finish developing it,
I know, that's what I was just
they'll
thinking.
be out of diapers, and
you strap this to the head of your baby, and
already there's a bunch of open source stuff already that you can use. You don't have to start from scratch,
It still takes forever to glue it all together. I've looked at it.
I think that all I need is I need something that's got buttons and one button is changing and one button is feeding, and just a basic log.
Okay, I'll give you an example of something like that, which is not related to the internet. There's a company called Flick, F-L-I-C, and these FLICs, they have these little buttons. And what you can do is you can program like an Android or an Apple phone to do something. It can be anything. So it could just be like a little text or something like that,
Oh, someone already made this. But I want to do it in Clojure.
Okay. Of course, yeah. You have to have a live.
It'd be cool if you had like a little box that had 3 buttons on it that was like a general purpose, like input device, for counting things. That ran Clojure and it.
What is?
I'm sorry, I was just a thing that had 3 buttons on it.
I just love like
The mouse.
I mean, someone had to invent this thing, right?
I'm expecting you to pull like a live mouse at some point up and just be like, oh, wrong kind.
I want to see the third hand. Like you pull one thing of another, and then a third hand comes up.
Oh man! Oh.
This
you
is
made
really
those headphones and the TV and.
It's cool. This is the first time I've ever been like really excited about.
So, yeah, hardware. If you get into this, it is honestly a very empowering thought that you could make your own remote control for your TV, or like you could just make it if you want it. There's nothing stopping you. There is absolutely nothing stopping you from making these things, and you can make them run Clojure.
I always think about stuff like things that are tedious to count or tedious to record. Like if I want to run laps, like it could just count how many laps I run, and I don't have to. I just put it in my pocket and I just start running. I don't have to count them. Or if I'm doing push-ups, if it's got centimeter accuracy, I could detect if I'm up or down, something like that. Tell me when I hit my goal of push-ups or silly things like that. Counting is such a pain.
What you probably just need is things to get easier, right? You need all these things to run ClojureScript or Clojure REPLs. They need to be like modular, and you can hook them together pretty quickly.
Yeah, that's what you need.
Very arcane. And
right. You need it to where it starts to become modular. Mm-hmm. You just set up one thing on each end of the lap thing you're running, and then put one in your pocket, and it just counts it. But then the problem is you have all this data. Where does it go? You got to store it somewhere in a form that you can use later. So you need some kind of generic place to log.
Yeah, but there are places like IPFS, for example, which is an interplanetary file system, and you can then, or there is OwnCloud, these kind of things where you can make sure that they're secure, so there's not these big giant corporations listening to your stuff.
We are slowly reinventing the Palm Pilot.
One thing I debate is if you get into hardware, arguably some of this stuff is a little bit like Legos. You're just hooking things together. You learn a little bit about the electrical signals and you hook it together. And the thing that I haven't decided yet in my mind is whether or not this stuff is more complicated or easier than software development. I mean, there's a lot to learn on both sides of the fence.
I'm sure you could start a fight on the internet about it.
Yeah. And see, I think there are more software developers than there are hardware developers. I think, and I think the hardware world is very much more esoteric, and that's why we're not all exposed to it, and we think of it as being this complicated thing.
But there's also there's different kinds of hardware developers, right? Like modular synth people are hardware developers, but I don't think they think of themselves as hardware developers. But they are using a lot of the same skill set as you're using to put together that microcontroller.
Yeah.
But also a lot of hardware developers are really software developers. Because you can't develop hardware anymore in the same way. You have to use software to write the plans to make hardware.
Right. But there's also a lot more like this. The hardware industry has been around longer. There's a lot more standardization, like the little lines on the resistor and what they mean.
Yeah.
The modules have been figured out.
Yeah.
A lot more.
I don't know. I mean, in electrical terms, yes, but I think there's a sort of Cambrian explosion going on in terms of like number of devices and possibilities and options.
CPU architecture.
To me, it's kind of really a nice space because either you don't have an operating system or you have like quite a lot of operating systems. Mm-hmm. So it's kind of a free space. If you think about like people are complaining all the time about, the 70s were fucking awesome, everything's great, and now everything's fixed, which is sort of true. But now this maker movement makes everything free again. You can write everything from scratch. You just have a driver or a bit of electricity and you can just do what the fuck you want. So I think they're quite empowering actually, and you can be quite creative with this stuff. I'm into it. I think it's really good.
I have like 3 or 4 different dev boards. They're like Nordic chipsets from TI, these ESP chipsets, one from, and they're each weird and different in their own way, and they have their own, they're all Eclipse based, but they're different compiler tool chains. It's a Cambrian explosion of weird, different stuff. There's no winner.
Know how that ended.
Yeah. 5G.
Yeah, but correlation is not causation. That's just.
Oh yeah, that's right. I forgot that.
I'm expecting you to pull these your TI things.
They're over there on the other side of the room. Yeah.
And now I want to start hacking something. It just sounds cool.
Yeah, I want to make something.
Some lights
yeah.
blinking.
So you can start with just getting a breadboard and hooking things together and do lights and stuff.
I would have thought for you, Mia, looking at the sort of room around there, some sort of water feeder for the plants, something where you can sense the,
They're all very easy. I water them all on Sunday.
But they need to water them.
But how do you know it's Sunday? That's what you need, an electronic calendar that beeps when it's Sunday.
So they wouldn't be easy if they weren't all living together. But once you get enough aeroids in one space, they produce enough atmospheric moisture to just make each other happy. That's the secret to plants, is you just can't have one plant. It will die.
I think the idea of single-purpose devices is really appealing.
Yes.
Yeah.
I hate using like one machine for everything. I think I have a fantasy often of, because I use my phone for a lot of stuff if I need it to be portable, but then you have to write an app for this thing, and it's like not. I don't know. It's not what I want
to go running or something. You're afraid you're going to drop it.
Yeah, or like I want a meditation timer, right? And so I just want to be able to like set it the way I want it, make it in a nice box.
Yeah.
Wooden box, and I press a button and it starts and it has a nice chime. I want to do stuff like that instead of like writing an app and I'm like doing this before I meditate. Like, where's my app?
Well, and also, if you put these things on your phone, then you're distracted as soon as you open it.
Exactly.
I think that's the really appealing thing about a single-purpose device is there's none of the distractions of a multi-purpose device where you just forget what you're doing.
That's right.
And it's an open ecosystem as well. You don't have to follow someone else's framework. You can just do everything from.
So you can, if you get into that area, you can get like. Here's more stuff I pulled off the floor. You can get little enclosures and you can put stuff inside. This is a car unlocking thing. But you can like put them inside of things and they become like appliances of a sense. Like if there's a board inside here, there's a board, if I slide it out, there's a board that you have inside there, but you can like put it in a nice enclosure, put some buttons on it if you need. So it doesn't have to be like a board, you're not sitting there pressing a circuit board to like do things.
I've seen some situations. You can just look on YouTube for all these various ideas, but some people will do things like they will embed these devices into mirrors. So when you wake up in the morning, this kind of stuff, it will tell you what the weather's going to be like, and it will tell you, the news and this kind of stuff. So you can just plug and play with all this kind of stuff, and you have your own connection to the internet using your Wi-Fi. You don't need to use someone else's tech to do it. So yeah.
That's really cool.
It's just so aesthetic.
Believe me, if you can understand how to program closure, you can do any of this. I mean, it is an investment in learning a little bit, how to hook the stuff together, but it's no more complex. It's within reach, right? It's not something you can't grok, certainly.
Mike, would you have some, like a resource list for people who are interested in getting started building their own closure script microcontrollers that we could add to the show notes so that anyone who wanted to, who's watching this and gets bit by the bug? To be honest, like there are like several like YouTube content producers that just explain electronics. I've learned a lot that way. And like Alan Walk is one who's pretty popular that I like because he explains things even just
so
like
clearly.
amassing the hardware.
Yeah, it's like anything else. Like you just start reading about this stuff and you just find this endless chain of stuff on the internet that explains it all. And
So I wanna shout out. If you go to the repo, the Esprit repo that's in the show notes, you'll see all of Mike's hard work in here. It's got all the plans and everything. And then there's a link that you can buy one.
Yeah, if you're too lazy, you can.
If you're too lazy to do it yourself, you can just buy one.
And as a matter of fact, I have my kids. My kids put these little things on there. That's their summer job. They because believe me.
Wow.
Yeah.
Child labor too. Support child labor.
Well, no, it's they're human pick and place machines, and I put them on there.
There you go. So it's actually taking jobs from the machines and giving them.
What do you call it if they're not paid, Mia?
Being a family.
Oh, okay. Okay.
Family business. Family business. You can use child labor. We're joking, right? I'm sure he feeds his kids.
Yeah.
They can find something on the floor to eat. There's lots of stuff on the floor. Hopefully gravity continues, because if not, man, stuff's going to start flying.
Is that why you've got these things called breadboards? Yeah.
Instead of the bread lines.
Yeah.
I've got breadboards. Let them eat cake. Yeah.
That's right.
But this is really cool. I want to try one now.
Yeah. So for me, part of it was like the whole rich hickey JavaScript has reach, ClojureScript has reach, and like the reach for a long time was just the browser. And then I'm like, I want to get this thing running on my phone, get it in there, get it self-hosted. And this is yet another part of that reach, pushing it into microprocessors. This language needs to run everywhere. Yeah.
Yeah, this is the first time I've been excited about this whole like maker hardware thing.
You can do it, Mia.
I'm excited.
It's not that hard.
I want to
get your soldering iron out. Yeah.
Bring some Clojure out into the world. Oh, I don't know if I'm allowed to solder anything.
Oh, come on.
Probably not. I'm not allowed to do anything.
I have lots of things that are dangerous, like hot air machines that you can melt the solder with, and high voltage. What else?
Wait until I eat the fetus. No solder until the fetus is out. No solder.
Oh, are you worried about the lead?
Yeah.
Okay, so there's lead-free solder. Yeah.
Oh, well, there we go. So it's completely safe.
Mm-hmm. It's like silver.
All that heat.
Googling the first person in history to Google lead-free solder pregnancy safe.
Like a soldering iron. You only burn yourself with that thing once, and then you learn.
Pregnancy safe solder. Oh yes, other people have looked for this.
Oh. Future moms who want to build electronics.
Yeah, apparently so. A lot of it is for stained glass.
Yes, yeah, exactly. For making stained glass, yeah. Or jewelry, and
Fun. Yeah, this is the first time I've been really excited about this hardware stuff, because you just want to put Clojure into the world.
Yes. It wants to live.
And you don't want to spend all your time debugging problems in other language.
Yeah, I want to debug something I already know how to debug.
Yeah, exactly. Mm-hmm. And be able to just REPL into it and be like, wow, what's going on?
Mm-hmm. Yeah. REPL's perfect for that.
So do you have a workflow for like putting an advanced compilation program onto it?
So it's actually pretty straightforward in that you would compile your stuff down to advanced, and then you make what I call a ROM or whatever. It's like a binary file that you then just use a serial program to load it onto there. And if you put and really a big part of this credit is due to the Esperino thing. It's the JavaScript engine. So you just take that advanced stuff and you put it in the place where it can read it.
Like the index.js or whatever.
Yeah, basically. Yep. And then it just goes.
That's cool.
Esperino just sounds so much like a Pokemon.
Esperino.
Oh, so that's this chip is called the ESP32, and there's the Esperino, and I have no clue what's going on with this ESP thing, so I just decided to call this thing Esprit. And I'm willing to confuse everyone, including myself. I don't know what it is, but yeah.
Well, this is fun. The Esperino website's great. It's got a lot of really good resources on it.
Yeah, you can so Esperino will work on even smaller chips if you just want to like program some JavaScript on a chip, Really cool.
There are all kinds of these little devices as well. It's like this a device that I like a lot called the Tessel 2, and that was one of the very first JavaScript engines that was ES6 compliant, and it's on an IoT board. And that's nice because it's very, very pluggable. It's very, it's designed to attach all kinds of things easily to. And it runs a very we've got to get Mike to port ClojureScript to that one.
I'll get right on it. Yeah.
But I think you could just run it probably pretty straightforward because it runs Node. So I think you can probably just run ClojureScript directly on that thing.
Oh, cool.
I have a Raspberry Pi, and I've wanted to. So I also have. Let me get it. Y'all keep talking. I'm gonna.
Is it on your
back.
floor somewhere?
Raspberry Pi probably feels like Raspberry Pi feels like a kind of IBM mainframe nowadays.
Yeah.
This thing is huge, man.
Yeah.
It's like got what, gigabytes of RAM?
Yeah, I know.
Instead of megabytes. What? That's the thing from the movie.
9000.
Yeah.
Oh, okay.
And it's hollow in the back.
Okay.
It's not really how. Like if you look at a picture from the movie.
Yeah.
It's not exact, but it's close enough to fool people. And I have a Raspberry Pi that will fit back here.
Yeah.
And I've always wanted to turn it into a voice assistant, just for the irony factor.
Yes.
And
you don't want to do that, Eric.
and just like hang it right here.
Yeah.
And just tell
Like
it
a
things
pulse.
and have. I don't want to like put what is that, Alexa or anything on it. I wanted to do one that was, more secure, and that I could program myself. But there's one called Mycroft that's an open source thing. But I don't know. I just haven't ever had the 10 hours or whatever it would take to sit down and do it. So I haven't done it. This is why I fear getting into hardware hacking, because
it's a time suck, yeah.
I'll buy all the stuff and it'll just sit on my shelf over there.
Yep,
Yeah,
that can happen with anything. Yeah.
Yeah. I don't know. I'm staring down the barrel of mat leave, so it might be nice to do something to maintain some of my computer knowledge.
Yeah.
Could it could work if you have some kind of like project with the baby.
We're just gonna wear the thing. Like you got all these cloth straps that you put the strap on, then you just stick
You wear the
in it.
baby.
Oh, you wear the
Yeah.
baby, yeah.
Yeah, and then like you just live your life, and like the baby chills, and thinks it's great. It's like, oh, like I'm being held. This is awesome.
Yeah, sure. Sure.
They're like needy potatoes, as far as I can figure out.
Yeah, so I've actually wanted to do something with Clojure because it turns out that Mycroft is just using a bunch of like open source research projects from universities for, speech to text conversion and stuff. And so like I could do that and just wire it all together with Clojure, run it on the Raspberry Pi. Of course, then I could program it. I could have like certain skills that I teach it. Like what's the weather, the basic stuff like that.
This is fun. I'm looking at the website.
For Esperino or?
For the Mycroft thing.
Mycroft, okay, yeah.
Didn't someone have a hard stop at 1?
I think that's gonna go.
Turns out it wasn't a hard stop. The meeting is actually next week.
Oh, that's a soft stop right there. That's long.
What is time?
We could go on that long if we wanted to.
So you know what? Ray needs the thing that tells you if it's Sunday.
Yeah. Well, calendars are overrated in my opinion. It's like the funny thing is, I used to, I don't know, in the sort of enterprise world, I don't know, 5 years ago, whatever. Feels like 5 years ago. Probably was 3 or 4 years ago. But I used to have like these calendars and used to have the phones. Everything was like linked, and I had all my calendars and all linked. And now I've got everything is disassembled completely. I don't know what I'm doing, but it seems like it's okay. It still seems to work, and don't miss that much. But I like the fact that I don't have all of these things integrated and controlled, and I don't have my whole day planned out by the hour anymore, which is good.
Who was it that had a calendar? When I was at the conj last year, he had a thing where it was a mini trash can that lit up when it was trash day.
Yeah, that was Philip Meyer. And what's interesting is
that's right, Philip Meyer.
He was very helpful because when at a certain point I was trying to get this thing to work back in like November or whatever, and I started tweeting a little bit about it, and I was like really struggling, and he hopped up and he's like, "Hey Mike, have you seen my talk about closure and microcontrollers?" I'm like, "What? You just gave one about it?" So like he helped me, and he taught me some learnings on which, that these bigger chips existed. So I'm like, what? Because I was trying to get it to fit on one that had like 512K of RAM, and I was like really struggling to get it to fit on there. And I'm like, how am I going to get a REPL to run that thing? Because you need like a megabyte to hold all the CLJS core. So he deserves credit for pointing out like, hey Mike, there's a bigger one. I'm like, what? I think this thing has like 4 megabytes. It's like,
and
of course it's not the gigabytes.
Is the 32?
Yeah, it's a 32-bit. Yeah.
Okay.
Yeah. Yeah, it's a pretty...
colleague who's a biohacking with Clojure, and I'm asking him right now what exactly he's doing with it.
Biohacking. Now, if you could get it small enough, you could embed it in your arm.
Yeah.
And then you have a REPL in your arm.
I think he wants to use it to measure his the accumulation of cholesterol in his arteries.
Okay.
But I don't know exactly how. I've just asked him to remind me of that.
So I've watched this talk by someone who put an RFID chip somewhere like embedded under his skin, subdermal, and he actually thought it was pretty cool because RFID chips are pretty reusable, like universally usable. So like he could program his doors to open for him when he like waved his hand over it, or he could use it to like rent a bike at the bike station. Yeah. Just wave your hand over the bike and it's yours. And he actually said that after a while he felt like he was very one with everything. That he would miss it if it was gone. Like, oh, you mean I gotta reach in my pocket and wave my wallet over something? Like things should just know me. And I think that'd be pretty cool. It's sort of like what was that? Get Smart, where you're like walking through the doors and they just open for you. There's just like hundreds of doors that you walk through and they just know you. That'd be cool.
As long as it was just like very, I don't know, I would just be very nervous about anything that someone else could hack into.
They could just read it right off your hand.
Yeah.
That's the nice thing about these really small microcontrollers where they don't have any internet connection.
Yeah, I want IoT without the internet. Like that's what I want. I want just a personal home network of these things.
Yeah, for sure.
You want the internet on a Wi-Fi on your LAN basically, rather than.
Yeah, I think that there's room for that.
Totally do.
And we have our the bassinet that we got for the thing.
Baby.
Yes.
They're called babies.
The child. The little human.
The child.
The recursion.
Yes.
Bond.
It actually, as far as I can tell, it produces its own local network. And
what?
Yeah. Well, so
it's baby network.
The Cisco bassinet.
It's just for the bassinet. It's just for the bassinet because you control it with your phone, but it's a smart bassinet.
Mm-hmm.
Yeah, it's a smart bassinet, so it will rock the baby more and make increasingly horrifying noises.
Wow.
depending on how loud the baby is. They're horrifying to me. Apparently, the baby loves them. They're like white noises. So, like level 4 is like this intense beating heartbeat sound that I guess is what it sounds like in there, which bless him.
Huh.
But you want to be able to control it locally with your phone from within the house. But obviously, we don't want our neighbors to be able to control our smart
beds. What's the idea of having a phone? Because all right, here's a story that just happened to me. My wife went to pick up our daughter, and they gave her at the daycare. They gave her butter, and she was like, "Oh, great, we needed one." We come home, and you open it up, and it says, "To use this, visit here, and you'll get the app." It's like, it's a thermometer. I just want, it even has its own LCD screen.
Oh, but well, those are the ones that were reporting the data about the temperature.
This one, it will report the data. They're trying to make a COVID map, but they don't have enough data to show anything useful. They don't. That's why they're giving them away. But it's supposed to be able to track, everybody in your family and whatever. So you're sharing this thermometer, but it's like I don't want to be relying on my phone to take a temperature. It just doesn't seem to be adding any value.
Would I like to have a remote control for this thing instead of using my phone as a remote control? Yes, but one of the things it does is report data about the baby's sleep patterns into this app. So you have the sleep log completely taken care of, and it's stored on your phone.
Well, okay, but then so this is one of those things that I experience when I you put some analytics on your website. Like, well, what do you do with the data? So I know how many visits.
Take it to the baby's pediatrician because they want to know.
I see.
So it's one of these things where it's tracking something that I don't have to.
Yeah, I've never tracked my baby's sleep. So
it's like
is it a thing now?
It's a whole thing.
Why does it matter though? Why does it? We of course all this tech is awesome, etc. But the non-tech perspective is also old school as of up until about 30 years ago was awesome. Yeah.
People have been maintaining baby sleep notebooks for as long as they've been having babies and had notebooks.
Sure, yeah.
So it's just moving on to something.
I do have to say that it
doesn't seem very hard to do.
When my second baby was born, we had a lot of questions like, wait, how old was my first baby when that happened? And we did have questions like that, and it would have been nice to know. Like, when was the first time she slept through the night? Those kinds of questions would have been really.
Also, things that don't seem hard to do when you are in a quiet office with 8 hours of sleep and a workday schedule become very hard to do when you're in survival mode with a newborn.
Oh yeah.
From what I've heard.
Well, I think we've all been there, but
I haven't.
You're about to be there.
Yes.
Yeah.
So,
but my point is that there is a lot of well-known sort of development milestones that you don't need to customize actually too much.
But then it's like, what if you say they're well known, but then what if your child deviates from that in some way?
Sure,
my cousin didn't talk until he was 2, and then it was full sentences, but that was stressful for his parents. So I think that this comes from my perspective as as a non-neurotypical person. The idea of things being well known, or well established, or normal, right? There's this idea of normal can be harmful if the child deviates from that in some way. So, and it's good to have it's benchmarking, right? It's good to have those benchmarks, but ultimately your child is different from other children.
Well, yes, of course. I guess the question is, what does it do for what does it do for you to? I mean, the whole point about typical milestones and benchmarks is that they're there to signal these exact cases where things aren't developing in a typical fashion.
Like
So then the question is, the question is like, oh, sorry, go on, yeah.
In the case of tracking the baby's sleep, it's like, this thing has like 4 different intensity settings. So you can experiment with it and you can be like, oh, I notice that my baby sleeps for 4-hour stretches when the intensity is at level 2, but it sleeps for 2-hour stretches when the intensity is at level 3. So I'm going to keep it at level 2.
You can A/B test your baby.
Yeah, you can A/B test the baby. There's a whole Facebook group devoted to A/B testing. Yeah, it's devoted to optimizing your baby's sleep. That's the big thing right now.
Okay.
But
fair enough.
This is exciting. I have to go eat. So.
Yeah, good.
Yeah. Okay. Yeah.
Yeah. Well, good luck, Mia. Good luck.
Thank you.
Yeah, I mean, it's a fascinating development, this stuff. So yeah.
Hopefully, we'll have a couple more of these, and then once one or both of us is presentable, maybe I can wear the thing onto the show.
Yeah, that'd be cool.
So.
Amazing. Yeah.
But I'm self-deprecating the baby. I'm self-deprecating the baby because the baby is still myself. But once the baby is his own person, he will just walk on water, I'm sure. But Mike, thank you for walking us through this journey
really
into
cool.
ClojureScript hardware. I'm really excited about this.
Yeah, the Clojure North talk will be out in a few weeks, I guess. It's their rough plan, I guess. I don't know. But now you have a preview, yeah.
Yeah.
Cool.
All right. Bye, everyone.
Are we going to wrap up, Eric?
Oh, do we have
an outro?
Okay. An outro. If you like the show, please subscribe. It's not live anymore because Google doesn't like that, I guess.
Yeah.
But you will get notified of new shows when they're uploaded.
We miss you. We miss the live. We miss the chats. We miss the interactions.
It's very annoying. Yeah.
We'll maybe figure it out one day when Google allows.
I mean, I think they're kind of bringing it back, right? Like
they're trying to do something. They're like,
they brought back Google Hangouts in the form of Google Meets, so it's only a matter of time before.
Wasn't that for money?
Why do you do this, Google? What is going on inside your company?
That is not a question you are allowed to ask.
But the other isn't the I mean, we have to look at some alternatives like unfortunately things like Twitch and Discord and other things like this, because I think having everyone on a Discord server, given the fact we have about 20 people that turn up, publicizing a Discord server will be quite straightforward. So I think we'll definitely have to work something out, because I agree, Mia. It's much nicer if we have the comments.
Audience, yeah.
I definitely miss that.
Yeah, it's fun. I didn't even think about a Discord, but yeah, people might really like that. Twitch is so hard to figure out logistically.
No, it's quite easy. You just tweet at the Discord server, and random crazies get involved.
Oh, good, my favorite.
Well, it's the same as the YouTube thing. I mean, there's no, in a sense, it's the same thing. We've got no control over who turns up on YouTube.
There's definitely a self-selecting group of people who want to hang out in the YouTube comment section of a Clojure chat channel.
Yeah.
All right. Well, bye, everyone.
Bye.
Bye.
See you next time.